Look at isotopes where we say iso means same, and then topos means place, right? And we took time to understand that. Now, isobars, what do they mean? This is the new next term that we need to actually explore as well. Um, when I say bars, yes, your mind should go to a weight, a heavy weight that you carry, right? Weight that we carry. Maybe if you go to the gym, you'll be able to see those weights that you can carry, right? Those are bars. You can call them as bars, right? Basically, isobars simply means same weight, same heaviness, right? Yeah. Um, so these are atoms, right? They have the same weight. And then when we refer to the weight of an atom, basically the mass of an atom, what did we say we look at? We look at the nucleus. Everything that is inside the nucleus, that's what contributes to the weight. We said electron don't contribute to that. So the only focus when it comes to weight should be the nucleus. And everything that's inside the nucleus, we sum them and we call it the mass number. So when we label the atom X, this is the mass number and this is the proton number. So the mass number here is the sum of the total nucleons in the atom, meaning the total number of protons and neutrons in the nucleus of that atom is what we call the nucleons, and it's represented by A. And that A is basically is a mass number, right? The mass number, because it's the one that contributes to the weight. So when we are talking about same weight, we are just referring to atoms that have the same A. Atoms that have the same A, the same mass number. That's isobar. Bar means weight, bar means heaviness, bar means you can see it as mass. So same mass, same atomic mass, same mass number. These are the atoms that we are referring to. But take note that these atoms are not going to be atoms of the same element again, like how we did it for isotopes. Isotopes, same place, so we go to the same place and find the same set of atoms. When we go to isobars, we are referring to atoms of different elements. The elements are different, right? So from this different family, or different positions, you can see atoms that are having the same weight, the same heaviness. That's what we mean by um, isobars. So take note that when you isobars, iso means same, bars means weight or heaviness or mass. So we are referring to basically to the same mass number, and the atoms that are involved should be atoms of different elements. Remember, I said the atoms of the different elements, not the elements themselves, but the atoms of the different elements. So, what other things should we look at? So you see hydrogen here, right? If you look at the bottom down here, is 1.008. If you look for everyone, there is something like that. That's just the average weight of all the atoms. We said hydrogen contains hydrogen 1 1, hydrogen 2 1, hydrogen 3, right? 3 1. So if you take the masses, the actual masses of all these two, and you divide it by 3, you find the mean. You are going to find that particular 1.008. That's what they found from the calculation. It applies also for the elements on the periodic table. You see the average mass of all the individual atoms. So if you put all the individual atoms together and you find the mean of their weight, that's what you put over there. So it's basically an average value for all the different atoms inside that element. So that's the mass, basically the mass. So all the atoms will have their own mass. The atom that they contain will have their own mass, right? So I want to show you some examples of isobars. So isobar, you can see it in this region: argon, potassium, and calcium. You can see isobar in that region. So argon has an atom inside it called argon 40. So argon 40. For the argon 40, it just means that if you have the argon, here is represented by 40 and here is 18. So that's 40. We also have calcium 40 as well. We have calcium 40, and calcium 40 calcium is having a mass number of 20, right? And we have a proton number of 20, and then here is also going to be 20. We have potassium 40 as well. Potassium 40, that's one of the isotopes of potassium. So you are going to have 19 here, and then you are basically going to have 40 here. So you see that this, and this are atoms of different elements: argon, calcium, and potassium. They are atoms of different elements, and then they are having the same mass number or the same mass. Because of that, all these three elements are called isobars, same mass, basically that. So yeah, that's what we need to look at. That's what we need to understand about isobars. And if you look on the periodic table, what you are finding on the periodic table, the mass and below there is not the mass of the atom, it's the average mass of all the atoms inside argon. Now if you enter argon, one of the atom of argon will be argon 40, meaning argon with mass number 40. So we took time to explain that difference between elements and argon, and we give you an analogy to actually picture how to see this. When we are referring to atom and we are referring to elements, that's the thing we are using here. So when we say isobars, isobars are atoms of different elements having the same mass numbers but different atomic numbers. Atomic number is the proton number. So atomic number is different, but then the mass numbers are the same for atoms. Take note, we are referring to atoms, not elements. They are atoms of different elements. So if you don't understand what we mean, you need to actually take time and then watch our video and understand the difference between atoms and elements. Atoms and elements. I told you earlier in the start of this video that chemistry is something that you don't have to miss the basics. If not, you get confused on the way. So don't just jump to the videos, but then take time, because we actually point out some things stuff and we are repeating them here. Okay, so I hope most of you that have watched and then have a clear understanding of difference between atoms and elements will now get it, what we mean by the atoms are there. But what we have on the periodic table, the masses that you have at the bottom here, like 40.078 and all that, the average masses may be different, but then the atoms, there are atoms inside them like argon 40. That is also having, we have argon 40, we have calcium 40, and then we have potassium 40. They have atoms of that sort. Yeah. So you want to calcium and gallium, they can never see 69.7. The average is around that side. So we cannot have argon 40 there. So basically that doesn't work for us. So that's about isobars, right? Atoms of different elements having the same mass. And then yeah, and a common example that we need to have at this point are argon, argon 40, potassium 40, and calcium 40. Let's meet in the next session and add another concept to the introductory videos of chemistry.